Hello everyone. Our next topic is hierarchical channel structure of LTE. So there are three different channel types defined in LTE, that are logical channels, transport channels and physical channels. Logical channels say what to transmit. What to transmit. Transport channels says how to transmit, and physical channels explains actual transmission of a data. Okay, there are three different channels defined in LTE. The other are logical channels, transport channels, physical channels. Logical channels say what to transmit, transport channels say how to transmit, and physical channels say actual transmission. Here, each channel associated with service access point, that is SAP, SAP is service access point. Each channel associated with SAP between different layers. So layers are, in a LTE protocol stack, you have a layers, RRC layer, PGCP layer, MAC layer, physical layer. Okay, so these are the different layers present in the protocol stack. So each channel here is associated with service access point between different layers. These channels are used by the lower layers to provide a service to the higher layers. So lower layers uses these channels to provide a service to the higher layer. So this first one, that is logical channels, provide a service at the SAP between MAC and RLC layer. Next, transport channels provide a service at the SAP between MAC and physical layers. Next, physical channels are the actual implementation of transport channels over the radio interface. Here you can see radio interface protocol architecture and the SAP between different layers. You can see here logical channels will provide a service for the RLC and MAC layers, and transport channels provide service at the SAP between MAC and physical layer. You can see in this diagram, logical channels are present between RLC and MAC, and transport channels are present between MAC and physical layer. So we'll study now these three channels, that is logical channels, transport channels and physical channels in detail. So first comes logical channels. I said that logical channels say what to transmit. Logical channels are used by the MAC to provide a service to the RLC layer. MAC is a lower layer, RLC is a higher layer. So logical channels are used by the MAC layer to provide a service to the RLC layer. So each logical channel is defined based on a type of information it carries. So there are two categories of logical channels. One is logical control channel and second one is logical traffic channel. So logical control channel. So in this logical control channel, control plane informations will be present. Control plane informations means other than the user's signal, user's traffic or vast traffic. Other than that, the control signals will be present in the logical channel, logical control channel. That is, signaling will be present in the control channel. Second one is logical traffic channel. In the logical traffic channel, user signals will be present. So this logical control channel is the first one and logical traffic channel is second one. This first logical control channels are used to transfer control plane information, and logic traffic channels are used to transfer user plane information. Again you can see here, this logical control channels are again classified into BCCH, MCCH, PCCH, CCCH, DCCH. Okay, so these are the classification of the logical control channel. Here Here BCCH, last two letters CH stands for channel, second letter C stands for control, first B for broadcast. It is broadcast control channel. So this five layers comes in logical control channel. So here C for control. So BCCH is broadcast control channel. Second one MCCH is multicast control channel. Next PCCH is paging control channel. Next CCCH is common control channel. Next DCCH is dedicated control channel. Okay, here again the traffic channels are classified into DTCH and MTCH. DTCH is a dedicated traffic channel and MTCH is a multicast traffic channel. Okay, so now we'll study each of the channels. First this logical channels and traffic channels separately. First one is BCCH. BCCH is broadcast control channel. It is a broadcasting means what? Sending an information to each and every cell, every mobile in the cell, right? Broadcasting is always downlink. In downlink broadcasting will be done. So broadcast control channel, about this is, it is a downlink common channel used to broadcast system control information. What type of signals we are going to send? That is system control information to the mobile terminals, including downlink system bandwidth, antenna configuration, reference signal. Next is MCCH, that is multicast control channel. Multicasting means what? Sending an information to group of cells or some, not to all the UVs, not to all the UVs, to some of the UVs. That is multicasting. Multicasting is also again a downlink. It is a point to multi-point downlink channel used for transmitting control information to UVs in the cell. It is used by UVs that receive multicast service. Next one is PCCH, paging control channel. Paging is again, it is a downlink channel that transmits paging information to registered UVs in the cell. Next is CCCH, common control channel. It is a bidirectional channel. So this above three, they are the downlink channels, but it is CCCH is a bidirectional channel, that is both network and UV both comes into picture here. So it is a bidirectional channel for transmitting control information between network and UVs. So between network and UVs, so it is a bidirectional. So when no RRC connection, implying the UV is not attached to network, that is UV is in a idle state. So in case of a RRC connection, ideal state means what? UV, our mobile unit, is not connected to the network. That is a ideal state. In that ideal state, common control channel signals are used. Next, DCCH, dedicated control channel. It is a point-to-point bidirectional channel that transmits dedicated control information between UV and the network. And this is used when RRC connection is available. That is, RRC connection is available means what? UV is connected to the network. At that time, this DCCH is used. Next is logical traffic channels. As I said before, there are two logical traffic channels: dedicated traffic channel, that is DTCH, and multicast traffic channel, that is MTCH. So first we'll study DTCH, dedicated traffic channel. So this logical traffic channels, what they say? They contain the user information. So dedicated traffic channel, it is a point-to-point bidirectional channel used between UV and network. It can exist in both uplink and downlink. Next is MTCH, a unidirectional point-to-multipoint data channel that transmits data from network to UVs. It is associated with multicaster broadcast service. Next is transport channels. So we studied this first one is logical channels. Next we study transport channels. Transport channels explains how to transmit the data, how to transmit the signal. So this channel is used by the physical layer to offer a service to the higher layer, that is MAC layer. A transport channel is basically characterized by how and with what characteristics data is transferred over the radio interface. That is channel coding scheme, modulation scheme, antenna mapping. These all things, it includes these all things. So LTE defines two MAC entities, one in the UV and one in the EUtron, which handle the following uplink and downlink transport channels. So what are that channels? So transport channels are categorized into two, downlink transport channels and uplink transport channels. In a downlink transport channels, you have DL-SCH, downlink. SCH is what? Shared channel. S for shared, CH for channel. BCH, that is broadcast channel. MCH, that is multicast channel. PCH, that is paging channel. Again, in uplink transport channels, you have UL-SCH and RACH. UL is what? Uplink shared channel. RACH is random access channel. Now we will study these channels one by one. So first one is downlink transport channels. Downlink, in this one, first one is downlink shared channel. It is used for transmitting downlink data, including both control and traffic data. Thus, it is associated with both logical control and logical traffic channels. The concept of shared channel transmission originates from HSDPA, which uses high-speed downlink shared channel to multiplex traffic and control information among different UVs. By sharing the radio resource among different UVs, the DLSCH is able to maximize the throughput by allocating resources to optimum UVs. Second one is BCH, that is broadcast channel. It is a downlink channel associated with BCCH logical channel, and it is used to broadcast system information over the entire coverage area of the cell. Next is MCH, that is multicast channel. It is associated with MTCH and MCCH logical channels for multicast broadcast service. It supports multicast and broadcast single frequency network transmission, which transmits the same information on the same radio resource from multiple synchronized base stations to multiple UVs. Next is paging channel. Paging channel is associated with PCCH logical channel. It is required for broadcast over the entire cell coverage area. It is transmitted on the physical downlink shared channel and supports UV discontinuous reception. Next is uplink transport channels. As I said, uplink, there are two types, uplink shared channels and random access channels. Uplink shared channel is just a counterpart of DL-SCH. It supports HARQ, dynamic link adaptation, dynamic and semi-persistent resource allocation. Random access channel is a specific channel not mapped to any logical channel. It transmits relatively small amount of data for initial access or, in the case of RRC, state changes. Next is physical channels, that is actual transmission of the data. Each physical channel corresponds to set of resource elements in the time frequency grid. From higher layers, the basic entities that make physical channels are resource elements and resource blocks. Resource elements is a single subcarrier over one OFDM symbol, and typically this could carry one modulated symbols. Next, what are resource blocks? Is a collection, or resource blocks is a collection of resource elements. So these two are the basic entities that make up the physical channel, that are resource channel and the resource block. We'll study this resource elements and resource blocks in detail in coming classes. Next is physical channel classification. Again, physical channels are classified into downlink physical channel and uplink physical channels. Downlink physical channels are PDCCH, PDSCH, PBCH, PMCH, PHICH, PCFICH. Uplink physical channels are PUCCH, PUSCH, PRACH. We'll study these channels now one by one. So first one is what? PDCCH. That is physical downlink control channel. It carries information about the transport format, resource allocation related to the DLSCH and PCH transport channels and the hybrid ARQ information related to the DLSCH. It also informs the UV about transport format, resource allocation and hybrid ARQ information related to ULSCH. Next one is PDSCH. That is physical downlink shared channel. Physical downlink shared channel. This channel carries user data and higher layer signals. PBCH, that is physical broadcast channel. It carries the BCH transport. It corresponds to the BCH transport channel and carries system information. PMCH, it carries multicast broadcast information and for MBMS service. Physical hybrid ARQ indicator. This channel carries HARQ acknowledgement, negative acknowledgement associated with uplink data transmission. Next is physical control format indicator channel. It informs the UV about the number of OFDM symbols used for the PDCCH. These all are downlink physical channels. Now we will study uplink physical channels. There are three uplink physical channels: PUCCH, PUSCH, PRACH. PUCCH is a physical uplink control channel. PUSCH is a uplink shared channel. PRACH is a physical random access channel. First one, PUCCH. It carries uplink control information including channel quality indicator, acknowledgement, negative acknowledgements for HARQ, that is hybrid ARQ, uplink scheduling requests. PUSCH, uplink shared channel. It carries user data and higher layer signaling. PRACH, physical random access channel. This channel carries the random access preamble sent by UVs. Okay, this is all about your channel structure of LTE. So you studied this logical channels, transport channels and physical channels. Thank you.